All right, hey Carter. We're doing 4-5. We're gonna do a little bit of these notes, maybe halfway through these notes. But these are max and min problems that are like story problems, okay? But they're not that hard. They're not as hard as what we've been doing. I feel like this is a baby step back, okay? So maxes and mins, they're gonna give us like things that involve like parabolas or cubic functions or whatever, and they're a lot of times having to do with area and perimeter problems, right? And so they give me equations for area, perimeter. I combine them together in such a way, and then it will give me a parabola. And they're wanting me to find the maximum, right? Well, if we're just trying to find the maximum on that, we don't even have to have the graph, right? You won't have the graph. But if we're trying to find the maximum, we just find where the derivative is equal to 0, right? And that'll give me the maximum point, whatever, right? Okay, so, what? We don't have an equation. So we have to find the equation for like example 1, okay? So, I'm going to go through this optimization problems, okay? So these are called optimization. Optimum means trying to find either the max or the min, depending on which one you're wanting. So if we're doing like area versus perimeter, right? A lot of times they'll give me like, you have 100 feet of fence, which is what example 1 is going to say. You have 100 feet of fence, which means I'm bound by the perimeter, right? Like I can only have a perimeter of 100 feet, but I want to maximize the area. That's an optimization problem because you're trying to optimize the area. You're trying to get the most bang for your buck, right? Okay. So if I'm doing 100 feet of fence, like I have options, right? Don't write this down. But I have options. Like this is a really terrible option. 1 by 49 by 1 by 49. Like nobody would do that, right? Because that's going to have a square footage of 49 square feet, right? For an area, okay? If I wanted to go a little bit better, I could go 2 by 48. Right? And 2 by 48, that's still 100 feet of fence, right? But it only has a square footage of 96, right? Okay, so I'm getting a little bit better. But, like, what's going to give me the best bang for my buck? Do you know? A perfect square will give me the best, right? So, if I have 100 feet of fence, in order to have a perfect square, each one would have to be 25, true? Do you know what 25 squared is? 625 is the maximum square footage that I can get out of 100 feet of fence, right? Okay. Now, sometimes they'll end up getting a little bit weird. What?
It makes me mad how much bigger it is.
What? Oh, I know, right?
Like
Yeah.
It makes sense, but like the skinnier it is.
Right. Like you wouldn't even be able to fit a cow this way, right? Like the cows, this would be like literally an alleyway. Like you couldn't even fit a cow that way. So yeah, it's just crazy how, and even going from 1 foot to 2 foot, like that just like made it a huge increase going just from 1 foot to 2 foot, right? And you still can't even fit a cow here, like sideways. You'd have to literally stack them as an alleyway, whatever, like if you're fencing cows. Anyway, but they might get also into scenarios where they say, okay, we have like a river over here on this side, right? So we get to use our 100 feet of fence, but we don't have to fence off that 4th side with our 100 feet, right? In order to do this, and like, now what dimensions do I use, right? Or they might say, instead, I have like this. I want to make 2 pins of fence, right? Like, what dimensions do I do here and what dimensions do I do here, right? If I have to make 2 pins of fence and I have 100 feet. 33 and a third. Well, yeah, you didn't know that? 3 divided by 3. But if it's 33 and a third, right? 33.3, what would be my square footage? Something above 900, whatever, right? So then it goes up from there, right? But if I have like 2 areas that I need fenced in and I have to have another little guy right here, now it's not going to be a perfect square here, right? Okay, and in fact, this guy isn't even going to be a perfect square, right? I'm not going to have 2 perfect squares together. It's going to be a little bit different, right? Okay, so we have that stuff to play with, but whatever. Got it? All right, let's go example 1. So, yeah, they don't even give me an equation, but we've got to, like, derive the equations. We've got to pull the equations out of here, okay? A garden is to be laid out in a rectangular area. I'm going to draw a picture. Here's my rectangle, okay? Protected by a chicken wire fence. What is the largest area, okay? So I want area to equal the max, right? That's my maximum area. If of the garden if only 100 running feet of chicken wire is available for the fence. We've already answered this question, but let's just show you how this works, okay? So the two things that we have going on is area and we have perimeter, right? Okay? All right, I want my area to be a max and I want my perimeter to be 100, right? Okay? So on the other side of this, let's go ahead and put out what the formula is for each one of these, right? So I don't know at this point, this is going to be a perfect square. I mean, I do, but I don't. Let's say we don't, right? So let's say that this is x by y, right? So the area of that thing is going to be xy. The perimeter of that thing is going to be what? 2x plus 2y, right? So these two equations are basically what I have going on here, right? Okay? And they call those the primary and secondary equations. Okay, so for some reason, I don't know why, they call the one that I'm trying to optimize, they call that the secondary equation. And they call this guy the primary equation. It doesn't really matter if you switch those two around. But we have a primary equation, we have a secondary equation. Right? Okay, and probably the reason why they call that one the primary equation is because I know everything about that, right? Like I have something on each side of the equal sign, whereas here I only know that that's the max. I don't know what number that's going to be, right? So what we do is we solve for one variable in the primary equation and then I plug it into the secondary equation. So we get to decide, like what variable would you like to solve for? You want to solve for x? Okay, so, what? Okay, so 2x equals, I'm going to say 100 minus 2y. Can I get away with doing that? Okay, then what? Divide by 2, divide by 2, divide by 2. Okay, so that cancels, that cancels. This is 50 minus y is equal to x. Yeah? Okay, we could have solved for y and it would have been easier. In this case, it's just as easy to solve for x as it is for y, right? In some cases, it will be easier to solve for one variable over the other, right? And you'll see that here in a second. Okay, so we have it solved for x, this guy. Now I'm going to take that x and I'm going to plug it in right here. Okay, so now I want the maximum to be equal to, I'm going to plop that stuff in for x and I'm going to have a y here. 50 minus y, do you see what I'm doing here? Yeah, like xy, this is now xy. Okay, so if I distribute, I want my maximum to be equal to, and can I do it this way, negative y squared plus 50y? Can I do that? Okay. That thing is a parabola facing down. It's this guy right here. Whoop. Okay, and we want to find the maximum. So we take the derivative. Deriv is negative 2y plus 50. Set it equal to 0. I'm going to bump the 2y over, so I have 50 equals 2y. Right? And we already know this answer, right? We already know that y is 25. Okay. All right. Good. Now, if y is 25, I'm going back to my diagram over here. If y is 25, that means this side's also 25, right? Okay, I know they have to add up to be 100, right? So I could plug 25 in here and solve if you want to. Like 100 equals 2x plus 2 times 25. Okay, I can do all the math. 2 times 25 is 50. If I subtract 50, 50 equals 2x, and x is also 25, right? Or you can just do the mental math and see, like from the diagram, that the x has to be 25 as well, right? So really x and y are the same dimensions there, which we kind of already anticipated. Whatever, right? Good? Yeah, that's all. Okay? Not bad. What do they ask for, though? What is the largest possible area? We didn't answer the question. Area equals 625 square feet. Are we square feet?
Yeah.
Square feet. Yep, that's the answer. So sometimes you got to be careful because they'll ask for that instead of asking for the dimensions. Whatever. Good. Okay, let's go to another where it gets a little bit harder. Okay. Picture included. All right. Here we go. An open box is to be made from a 16 by 30 inch piece of cardboard. Okay, so this is how they make boxes, like in this style, right? They take one thing and then they'll cut out a little thing right here and they'll cut out one on each corner, right? I mean, not every box, but some boxes like this, right? And then they'll, whatever, right? Mm-hmm. And then they fold them up, okay? But the deal here is I don't know how big I'm notching those out because I want to figure out how big I notch those out so that it encloses the maximum volume, right? I want to maximize my volume probably, right? Is that what it says? Woo, what size to the largest volume. Okay, so I could notch it out real small and have it be a flat box, in which case I have a volume here, right? Okay, or I can notch it out real big and make it a tall box, like my paper recycling box, right? This is a really, why am I drawing it that way? Anyway, he's a lot taller, right? But he's going to be like narrower at the base if he's taller, true? So I have to like balance those two things and figure out what's going to give me the best bang for my buck again, right? Okay, so we've got to figure out how this is going to work, and we have two things to deal with. We have like the surface area kind of thing going on. Right, right. So the way that they have drawn here, okay, if we fold it up, do you see how they get this? 30 minus 2x. It goes from being 30 inches long to like if I cut this out and cut this out, now this length is only 30 minus x, right? Okay, so that makes sense. 16 minus 2x right here is the same way. If it's 16 to start with, and I notch that out, 16 minus 2x, got it. But then he's x units tall, right? Okay, now I think we only have one formula here. We don't even have to worry about the perimeter because the perimeter is already included. The perimeter was 16 by 30, right? So we really only have our maximum volume, and I need to find volume. How do I find the volume of that thing, of this thing? Does it matter that there's not a top on it for volume? No, for surface area it would, right? Okay, but for volume it doesn't. So how to find the volume of that like rectangular prism? Length, width, height, base, width, height, whatever you want to call it. All three of those dimensions times each other, right? So 30 minus 2x, 16 minus 2x, and then by x tall, right? Length, width, height, or base times height times whatever. Which ones would you like to multiply first? What?
Do we multiply that 1x?
You could distribute this x through, but we can only multiply two at a time, right? So like we'd have to like FOIL these two and then run an x through the whole thing, you know? That makes sense?
Oh,
Should we do the last two? So we'll make this 16x minus 2x squared, and then bump him through and FOIL him here. Should we do that?
yeah,
Sure. Okay, now what you can't do we understand this? What you can't do is run an x through here and run an x through here, right? Like we have to pick one or the other, right? That make sense? Yeah? Like when you're doing area of a triangle, like this is kind of off topic, right? Area of a triangle is 1/2 base times the height, right? Let's say the base is 8 and the height is 6, right? I take half of 8, that's 4, but then I don't take half of 16 as well, right? I would only take 4 times 16, true? Or 4 times 6, I mean. So you can only run the x through here, you can't run the x through the whole thing. Got it? Okay. So however you want to do that, let's just, whatever. So let's just do through those last, that last group, and now let's FOIL. Okay? So this guy times this guy. All right, 16x times 30x is like 480x, I think. 16 times 3 is 48, I think. Okay? And then we're doing this kind of backwards. Whatever. Let's do 30 times negative 2x squared. Negative 60x squared. Whatever. I'm trying to like, I don't know how I'm foiling this out. Nothing's in order. Nothing's in order. Negative 2x times 16x is negative 32x squared. And negative 2x times negative 2x squared is positive 4x cubed. Ooh. Okay. Then, if I put in order 4x cubed minus like 92x squared plus 480x. Woo! And that's my volume. So I want to maximize that volume. Okay. We got to take the derivative first. Yeah. We got to take the derivative first and set him equal to 0. And we'll do all the thingy things from there. This guy looks like a cubic function. Okay, but we'll talk about him here in a second. He's going to be a cubic function. All right. Derivative equal to 0. Derivative is 12x squared minus 184x. Yeah. Plus 40 equals 0. Okay. I wonder if we can divide that by 12. I bet we can. Can we divide each one of them by 12? No. Boo. Can we divide by 4? Can we divide by 6? No, we can't divide by 6. We can divide by 4, though, I think. What? So 3x squared minus, that would be 46x. Is that true? Plus 120 equals 0. Okay, so that's my derivative. This is my deriv. I'm going to label him so I can come back to him. And now what? Complex trinomial. 3 times 120. Ooh. 360. Multiply to get 360. Add to get negative 46. So we know that they have to both be negative, right? Right? In order to be a positive 360 when you multiply, but add together to give negative. So... 30 times, what? What's 30? 30 times 12? Okay, that's a close split because that would be 42. Is it 30 times 16? What? They have to add to get negative 46. Oh, 30. Oh, duh. What? Boo. 36 times 10. Whatever. You didn't know.
I'm so lost.
36 times 10. You're so lost? Are you lost? Do I need to back up?
No.
Okay.
I'm not
Okay, we're at the derivative. We're breaking them down.
Yeah.
We're simple trinomial. And we got negative 36 and negative 10. Okay, so I'm going to set them up into 4 pieces and factor by grouping. So 3x squared stays, plus 120 stays, minus 36x minus 10x. Blah, 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 blah. You don't remember how to do complex trinomials?
You multiply the outside and
Yeah.
then find their...
Find what you get to get the inside.
Okay.
What adds together to get the inside.
Okay.
It's kind of like a simple trinomial. You're multiplying to get this and adding to get this. Instead, you're multiplying to get this and adding to get the middle.
Okay.
Yeah, whatever. Okay, so take a 3x out. Left is x minus 12. Take a negative 10 out. Left is x minus 12. Okay. My two groups are 3x minus 10 and x minus 12. X equals 10 thirds and x equals 12. Okay. So, all right. Okay. Problem. 12, well, the x is what we're notching out, correct? Okay? We have a piece that's 30 to start with. And if I notch 12 out here, and 12 out here, 12 here, 12 here, the base of that would be 6. True? Yeah? And he'd be 12 tall and 6 at the base, right? If this is 16, and I notch out 12 here, and I notch out 12 here,
That's not
the base is like negative 8 units, right? Like I can't notch 12 out, true? So we know that, and that's why this little humpy guy only has one of those, right? Okay, what's happening to this thing, by the way, since this was a cubic function to begin with, it looks like this, right? That's what it's doing, okay? It's just that down here is going to yield us a negative volume. Does that make sense?
We don't
Right?
want minimum anyway.
And that's at whatever, 12 right here. 12 is going to yield us a negative volume. What's up?
Wait a minute.
What do you mean? Right. If it goes back up, yeah, like it would have to stop here, realistically. But like, I'm just talking like the function in general, like it would look like that. But so yeah, like this doesn't even exist. This really doesn't even exist either. Yeah.
Oh,
Yeah,
you're gonna
like
get
that's in
into
not real land,
volume.
and this is not in real land either, right? Okay, but like that's what my function's doing. That's why he's going down, whatever, right? So we're only looking at this guy right here. We're looking at 10 thirds, right? 10 thirds has to be my x, and what should the sides of the squares be to obtain a box with the largest volume? 10 thirds, or 3 1/3 inches to notch out. 3 1/3. And they don't even ask for the volume. We could figure out the volume from there. So we just say 3 1/3 inches is what we're notching out. Like that. Okay? Beautiful. How about that? Does that make sense though, why 12 doesn't work? And like he would go down and whatever. Negative volume. Got it? Okay. Beautiful, 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 beautiful. Okay? Wonderful? Good? Alright, should we do one more and then we'll stop?
Why not?
We still have a lot of time, but like I don't want to overload. Whatever. Maybe this isn't. I don't know, is your brain overloaded yet? Tate's always brain on max capacity.
That's not even true.
Okay, whatever.
What does that mean?
I don't know. You're just looking at me like
That was
you got
so,
stars in your
that
eyeballs.
was so rude of her.
Okay, whatever. All right.
I'm gonna tell Mrs. What's her name to put in the closet.
Whatever. Okay. This figure shows an offshore oil well located at point W. Here's my oil well. And it is in the ocean, like many of them are. 5 kilometers from the closest point on A to the short line. So, perpendicular to the shore, 5 kilometers. Shortest distance. Okay? But then we got somebody over by P. Something's happened at P. Oil is to be piped from W. Oh, I like this question. This is a hard question, folks. Oil is to be piped from W to a shore point B. That is 8 kilometers from A by piping on a straight line underwater from W to the shore point, like 2P and blah, blah, blah. Okay, so here's the deal.
I bet it's one of those. I knew it.
What?
How'd you know?
So
Reducing
can we
the
just-
cost to what?
You're talking about me?
Yeah, I was gonna say, can we just keep it like 2 and 1x for the cost?
What are you talking
Just
about?
wanna write your little
Why
comment
2
down.
and 1?
Because 1,500,000.
Huh?
Oh, I get it. Potentially, right? So we understand what the problem is here, right? Like, it would be nice if I could just go at a perpendicular because then I know exactly what it was, right? But this is costing me $1 million per whatever, and this is costing me 500,000, right? Okay? So if I go that way, that is the longest distance, true? Like this right here is the longest distance, right? This would be a shorter distance, okay? But this one is the one that has the shortest amount at the $1 million mark,
So
right?
would those be our only 2 options?
What?
Like shortest distance to shore, or like shortest distance overall?
Yeah.
You don't even have to consider any other options.
Yeah, but the problem is we don't, yeah. We don't know where this point is located though.
Well, we can find that out anyway.
Well, the shortest distance overall would be this one, right?
Well,
True? But I don't want to
that's
do that
not
because that's $1 million no matter what, and that's the shortest overall distance. But that's going to cost me the most money per kilometer,
It's
right?
not half as short as.
Right. It wouldn't be half as short as this, right? Okay, to make up for it. So that's the problem. That's why we got to pipe here and then we got to go there, right? So we got to figure out what that is. Whew. Oy vey. All right. Okay. Whew, we got to figure out what our equations are. I am.
You can't send this to him
He's
so
not gonna
private.
watch it.
He's not going to watch it. Okay. They didn't even hear anything.
Hey, Carter!
All right. Cost of laying pipe underwater. Why does it cost more to lay pipe underwater than it does in land?
Because they have to have
Does
special
that,
scuba
does
divers.
that even pertain to the math we're doing?
I know, but like, why would it cost more?
Because they have to have like scuba divers.
Because you're like underwater. Of course it's harder to do, right? I don't know. Probably costs, it like takes more time and all the things, right? Okay, where should point B, P be to minimize the cost of laying pipe? All right. Oy vey. Oy vey. Okay. No, because there's no angles going on here. I don't think. Okay, so the deal here is that this is 8 kilometers, right? That whole thing, okay? So what we've got going on here is that, yeah, okay. They've marked this out as x. That means this is 8 minus x, okay? Now, we're going to use the dimension 8 minus x because that's going to give me that, right? Okay? But then what is this distance right here? Because those are my 2 sections of pipe, right? Okay, we've got 8 minus x is that red, and then the blue would be the Pythagorean theorem with x and 5, right? So x squared plus 5 squared equals c squared.
Good.
So it would be like the square root. This guy is the square root of x squared plus 25. Is that true? Ugly. Okay, all right.
No, we're good.
Okay, we're talking about cost now. Okay?
Oh.
All right, we're talking about cost. So we said, since you boys weren't paying attention, we said this amount of pipe right here on the bottom is 8 minus x because it's 8 kilometers. If this is x, whatever, that's 8 minus x, okay? This other piece of pipe right here is the Pythagorean theorem with 5 and x, right? Okay? Yeah, right? And the Pythagorean theorem, if we do that, it's the square root of x squared plus 25. That's what this thing looks like. So we've got our 2 pieces, right? Okay? Now, the deal is, this is costing 500,000 bucks, right? This is costing $1 million bucks. So if we're trying to figure total cost, I have my 2 chunks, right? This chunk plus this chunk added together, okay? The one chunk is 8 minus x units long, but that's costing me $500,000 per each one of those. True? Per whatever feet that is, right? And this one is costing me $1 million bucks per each one of those. And those are x squared, the square root of x squared plus 25. Okay? So that's my total cost. That's my equation. That's taking everything into consideration. Gross.
And we couldn't.
Gross.
produce that?
Nope. I don't think so.
Alright.
All right, so let's maybe do this. Before we take the derivative, let's distribute him through. We're going to have huge numbers. This is 4 million minus 500,000 x. So I've got 2 terms there, 1, 2, okay? And then this guy we're just going to leave as 1 million square root of x squared plus 25. Actually, since we're going to take the derivative next, I'm going to go x squared plus 25 to the half power. All right. Beautiful. It's not going to be that bad. I promise you. Oh, you'll see here in a second. Okay. Derivative. Is she wanting back in?
I'd assume that's what all that ruckus is about.
Oh, she's just a pain in my patoot. All right, so derivative. We have 3 pieces, right? Derivative of 4 million?
0.
Boom, gone. Derivative of this guy? Negative 500,000. X is gone, right? Okay. All right, how do I take the derivative of this thing? Chain rule. 1/2 comes down in front, right? What's 1/2 of a million? 500,000. Times x squared plus 25 to the negative half times 2x, the derivative of the inside. Okay. Okay. All right.
I don't like that.
We can do this, I think.
Oh, these are cute.
I think we can. All right. All right. And we want to set that equal to 0, true? Okay, so let's fix this. I have 2 pieces, right? Like I have this piece and I have this piece, right? Can we just divide off a 500,000 and make it shorter, right? Okay, so this guy is -1 and this guy is a +1 now, right? Okay,
So we could have.
so I have -1 plus 2x over the square root of x squared plus 25. Do you see what I just did? This guy went to the bottom. 2x times 1 stays on the top, and I have them set equal to 0. Great. Now, does the bottom cancel out? Can I multiply him over and the bottom cancel out? No, because this 1 is here. Boo. Okay, so what do we do now?
Add them over.
Let's add them over. Let's do the 2x over the square root of x squared plus 25 equals 1. Now what?
Multiply it.
Now multiply them over, but he still doesn't go away, right? 2x equals the square root of x squared plus 25.
Square it.
Now we square it. So square it, square it. If I square the left, what's this guy? 4x squared equals x squared plus 25. Okay, we're getting closer. We're getting closer. Subtract the x squared. We get 3x squared equals 25.
Square root that.
X squared equals, no, divide by 3 first. 25 over 3, whatever that is. And we take the square root. We put the square root in so it's plus and minus, but x is representing distance, right? So it's only positive. So what's the square root of 25 over 3? Give me like 2 decimals. 2.89.
This is what x is.
Woo! And that's the derivative set equal to 0. So that is the shortest, like giving me the minimum whatever, right?
You didn't have to keep in those stupid numbers.
Minimum amount. Okay. Just because I'm curious. Just because I'm curious. Oh, I should have left that equation. Hold on. Just because I'm curious.
What is it?
Just because I'm curious. Does that say that it's that much money per kilometer? Yeah, per kilometer. Okay. So, how many kilometers are we going by land? 8 minus 2.289?
5.11.
5.11 kilometers by land, right? Okay. All right, how much money is that costing me at 500,000 a piece? How much money is that costing?
Holy.
That much? Okay, that much. All right. Now, let's plug him in here. 2.89 squared plus 25, square root of that. That is how many by C? How many kilometers by C? 5.7, we'll go 5.78 at a million, right? So 5 million, 7, what did you say? 775? Okay. That much plus that much. Ooh, we're above 8 million at this point.
Whoa.
330,000. Woo! But that is the cheapest. That's the minimum. Look at all that work for that one thing. But seriously though, folks. Right. There is somebody who is literally doing these things to try to calculate the cheapest route, true?
If you go straight to the shore.
Like, this is an actual, like, an engineer who is designated to do this for a job, right? Like, they probably have a computer helping them, and maybe it's doing the whole thing for them. But, like, literally, if you're saving millions, that person, like, let's throw a couple $100,000 their way for saving us millions on this project, right? They don't care. You're going to be paid oodles of money if you're the person figuring this out, because you're going to be saving them millions, true?
So you're telling me I should go into oil pipeline?
I'm just saying, you should go into engineering and whatever, okay?
That'd be
If the cost, okay, so what was the answer to this even? If the cost of laying pipe is that, blah, blah, where should the point P be located to minimize the cost of laying pipe? 2.89 from point A, right? Whatever that is. Okay, so good. Make sense? Woo! All right, there you go. We'll stop there. Okay, goodbye, Carter.
Bye, Carter.